Hello and welcome to a mini-series of Biosolve IT instructional videos on SeeSAR. We will showcase few selected application scenarios that will help you manage your work do more easily with SeeSAR. And you can see SeeSAR here. When you open the software, you will see that it's a very simplistic interface. Only the most necessary features allow you to concentrate really on your work, analyze protein ligand complexes, or improve molecular structures in the protein active site and seeing the result this has on the affinity. Explore the SAR around your ligand. When you start the software, you will see this window here, which allows you to either directly download from the PDB website, or you can select a protein complex from your hard drive or from your network. We will look at 3-IPH today, which is a p38 Map Kinase and a so-called magical methyl. So here, when you load the structure, you will see the protein and the ligand in 3D. Those little red dots are all water molecules. And in the table view here, you have the ligand entry and all the other small molecules with their corresponding estimated affinity. So we can see that this is a very tight binding molecule, which is in very good agreement to the experiment. The experimental binding affinity is around 25 nanomolar, so that's in perfect agreement here. We can now click on this entry and get a more detailed view on binding. We see the ligand, the ligand's atoms are surrounded by these green spheres, which size scales directly to the contribution of each atom to the binding affinity. And it becomes immediately apparent that this methyl group here actually is the atom with the largest contribution. And this is indeed the magical methyl here. We can put this in numerical perspective by clicking on the atom. We see the Hyde score, which is around 10 kilojoules per mole. That is 1 to 2 orders of magnitude in binding. The affinity for this atom is decomposed into the ligand part and the receptor part. And if we want to know which receptor atoms contribute to this binding affinity here, we'll simply click on this little I symbol, and that reveals which receptor atoms, which amino acids are contributing here. So we have alanine 51, we have valine 38, and we have lysine 53. So we could now go into the editing mode, and we see on the side here a little editor opens. This white fog around the ligand indicates areas for exploration. So these are pockets that can be filled by atoms or groups. And we will now remove this magical methyl here and see what happens. So for once we can see that there's also more white fog around the benzene ring, which is to be expected because the atom doesn't fill this area anymore. We now bring this atom into the table, and not very surprisingly, we see that the affinity has actually dropped. So it's gotten a little bit worse here. Another feature of SeeSAR is the analysis of the conformation of the molecule, which can be revealed when we click on this little button here, Show Torsion Quality. These torsions are derived from statistical analysis of torsions in the CSD. So the larger the distribution of a particular torsion in the CSD, the greener the color. So yellow means it's just not a very abundant torsion, but it does exist. Green means it is widely abundant in the CSD, and red means it almost never occurs. So the second feature of this magical methyl, actually, which contributes much more to the binding affinity of this compound, is locking these two biphenyls here into a specific torsion angle. Now, by removing this, the torsion angle actually has gotten worse. So let us reintroduce the magical methyl and see what happens with this torsion here. Okay, so we will again save this and leave the editor. So we now see that the binding affinity is back to where it was. Actually, it's still a little bit better. And the torsion angle here has changed from red to yellow. So this means this torsion is a little more favorable than the one before. And it locks this arrangement into a very favorable torsion, which helps binding of the molecule to the protein. So this was the first of a mini series of instructional videos by Biosolve IT. We hope you enjoyed this and hope that you will stay tuned for the next few videos here.